Okay, boys and girls, last short little video. I promise you won't have to see my face again until you at least get to the next investigation part. But here they summarize some of the materials that you guys have come up with and some of the materials you may not have come up with, but that seem to be a good fit and materials that would be easy for us to find in order to try to insulate the cups. So here, they'll show us what they did. Here is a sample of one of the ones that they did. They took the smaller cup and the larger cup, and in between those two cups, they put in some plastic bubble wrap. You know, the things that come in when you order something online and they ship it with the bubble wrap to try to keep it safe and secure. And when they get them, everybody loves to pop those little bubbles. Those are fun. So they put hot water in one of the cups and cold water in another cup with the bubble wrap insulation. And then they measured the temperature of the water before they left it in the cup, and they left it in the cup for a little while and then measured the temperature afterwards again. So they tested this with a few different materials, and what they came to find out is which ones worked best as insulating materials and which ones did not work best. So we can take a look here and we can see that they used paper towels because again, that's something we can easily find in our house. They used feathers, which I would not have in my house in order to try to get for you. They used foam, excuse me. They used bubble wrap. They used newspaper. They used socks. They used yarn. And they used tissues. So most of these are things that are easily available in our house. I'm not sure most of us have feathers in our house, but I suppose if we split apart our pillows, we could probably find some, but that wouldn't make our parents very happy. So when they looked at the paper towels, they saw that in the hot water cup, the change in temperature with the paper towels used as insulation was 7 degrees. And with the cold water cup, the change in insulation was, the change in temperature was 1 degree. So the paper towel worked fairly well with the cold water. But with a change in temperature of 7 degrees, I wouldn't say it worked very well with the hot water. Let's take a look at how feathers did. Feathers with the hot water, change in temperature was 6 degrees. So that was a little better than the paper towels because with the paper towels, it changed 7 degrees. With the feathers, it only changed 6 degrees. So the feathers are a better source of insulation than the paper towels. There was less energy transfer with the feathers than there was with the paper towels. With the cold water, the feathers changed 2 degrees. So ironically, the paper towels only changed 1 degree with the paper towels as the insulator in the cold water, but the feathers as the insulator, which did better in the hot water, did worse in the cold water and let the cold water change 2 degrees. Now we can take a look at the foam. The hot water with the foam in as the insulation changed 2 degrees, which again is much better than the paper towel change of 7 degrees, much better than the feather change of 6 degrees. 2 degrees is a better change, less change, which means that it is a better insulator and there's less energy transfer between the objects. Cold water didn't change at all. So the cold water temperature in the beginning was the same as the cold water temperature at the end of the experiment with the foam. Now this could be like the foam cups like you get in Dunkin' Donuts, that kind of material in between the two. And it does work pretty well for Dunkin' Donuts in keeping their coffee warm because that's what they tend to use. Bubble wrap. And again, that's what they showed you. The hot water changed 2 degrees, which again means there's less energy transfer with the bubble wrap than there was with the feathers or the paper towels, and it was the same amount of energy transfer as it was with the foam. Now the bubble wrap on the cold water changed 1 degree. So again, not very much change. Newspaper on hot water changed 8 degrees, which is our worst change yet. Paper towels changed 7 degrees, feathers changed 6 degrees, foam changed 2, bubble wrap changed 2, but newspaper changed 8 degrees. So far newspaper is our worst insulator because there was the most energy transfer with the hot water. Our cold water changed 3 degrees. 3 degrees. And again, 3 compared to 1, compared to 0, compared to 2, compared to 1. Newspaper is our worst insulator of cold water up to this point. Socks. Hot water changed 5 degrees and cold water changed 1 degree. So the cold water was kind of on par with everything else that we have tried. It didn't change very much, but it did change a little. The hot water changing 5 degrees, it was better than the newspaper, it was better than the paper towels, it was better than the feathers, but it was worse than the foam and worse than the bubble wrap. Yarn also changed the hot water 5 degrees and the cold water 2 degrees. Tissues changed 8 degrees and 2 degrees. So again, tissues are along the same lines as newspaper, not a very good conductor. There was a lot of energy transfer with an 8-degree change in temperature, and that was what we were trying to avoid, was that energy transfer. We did not want to see that energy transfer because that's what insulation will stop. So it's going to get us to some questions right here. And the questions are, what material best reduced energy transfer between the surrounding atmosphere and the internal contents? So let's go back and take a look at this. What material best reduced energy transfer? Got to get all the way back. There we go. So what material best reduced energy transfer? Now I just want you guys to think about this answer for a moment because you're going to answer this on your Nearpod when we get back to it in a minute. So just think in your head which one you're going to write down. Which material was the best insulator out of these 8? In order to find out which was the best insulator, are we looking at a large temperature change or a small temperature change? Which one's going to be a better insulator? So now that you have the number in your head that it should be for the insulation material, let's go back and take a look at the second question. At the particle level, why do you think some materials act as better insulators than others? So once again, I'm going back to the materials because this will also be answered on your Nearpod. And I want you to tell me, at the particle level, why do you think some materials act as better insulators than others? So again, here is all of our 8 materials that were tested. So we want to know at the particle level, why were some of these better insulators than others? And I'll give you a few minutes to take a look at this sheet before I send you guys off to your Nearpod to answer those 2 questions. Okay guys, and again, this was the very last video, so you don't have to hear my voice or see my face again today. See you later.